Test. Okay. Hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing Stats and Math at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school level and college level. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. All right. Our first question today is asking us, what is the square root of 15 times the square root of 6? Okay, so let's copy down the question. So, what is the square root of 15 times the square root of 6? So first, let's present square root of 15 and square root of 6 first. All right, so we present square root of 15, which is root 15, and square root of 6, which is root 6. And then using the radical rule, which is look like this. So root a times root b is equal to root a times b. Thus, we can simplify the above expression as root 15 times root 6, which is equal to root 15 times 6. Yep. And 15 times 6 is equal to 90. Right. So our next step, we need to simplify the radical expression using prime factorization. Right. So we just need to express the radical as a product of its prime factors. So 18 is also equal to 9 times 10. And since we know root 9 is equal to 3, so we can have 3 squared times 10, and then we square root that, so we can take a 3 out. So we got 3 root 10 left. Therefore, let's write our conclusion. Therefore, the value of square root of 15 times square root of 6 is 3 root 10. Right. So that's all we have for this question. Let's leave a comment. Right, so coming up, we're asking how many lines of symmetry. Does a regular pentagon have? Right. So first, let's draw the diagram of a pentagon. So it should be something that look like this. Yep. So if we draw the lines of symmetry, there are 1, 2, and 1, 2, 3, 4, and 5. So we can write our conclusion. So a regular pentagon has 5 sides and 5 lines of symmetry. Yeah. And also remember the number of lines of symmetry in a regular polygon is equal to the number of sides. Yeah. So another example could be triangle. So for triangle, we know that there are 3 sides and also 3 lines of symmetry. So that's 1, 2, and 3. Yep. So that's all we got for this question. So solution is correct. Well done. Okay. So next question is asking us, how do you simplify complex fractions? All right. So first, let's define what a complex fraction is. So, definition: complex fractions are fractions where any or both of the numerator and denominator contains a fraction. Right. So some examples could be so 1/2 is our numerator, and then over, let's say 2, and let's say 2 over 3 over 4 over 7, and let's say 5 over 7 over 8. Yep. So these are the what we call the complex fractions. And in terms of how to simplify all these complex fractions, let's follow the general steps. So step 1, we always need to find the common denominator. And step 2, we need to multiply the common denominator to the numerator and denominator. And our last step will be simplified. Right. So let's try an example. Let's see. Okay. So let's start a new page. Let's see. We have 1 over 2 over 3 over 4. Right. So the denominator of two fractions are 2 and 4. Yeah. And these two fractions are just 1 over 2 and 3 over 4. So the common denominator of 2 and 4 is just going to be 4. So the common denominator of 2 and 4 is 4. So now let's just multiply 4 to both fractions. So we'll have still 1 over 2 over 3 over 4. Then we times 4 for both numerator and denominator in order to maintain the same value of our original fraction. So we will get 1 over 2 times 4 is just 4 over 2. And 3 over 4 times 4 will be 12 over 4. Right. So although this looks worse than our initial complex fraction, we can see that 4 over 2 and 12 over 4 can be simplified to 2 and 3, respectively. So let's write it down here. So 4 over 2 can be written as 2, and 12 over 4 can be written as 3. Thus, 4 over 2 over 12 over 4 is equal to 2 over 3. Yep. So that's the answer. Right. And there are also another way of solve complex fraction is to multiply the inverse of the denominator to the numerator. So let's start a new page. So another way so we need to multiply the inverse of the denominator to the numerator. And since fractions are quotient, we multiply the inverse of the denominator is the same thing as dividing the two fractions. Right, so still we got 1 over 2 over 3 over 4, and this is equal to 1 over 2 times 4 over 3, where 4 over 3 is the inverse of 3 over 4. So we get 4 over 6, and then we just need to simplify it because we realize that 4 and 6 are both even numbers, so we can divide the top and bottom by 2. So 4 divided by 2 is 2, 6 divided by 2 is 3. So still, we got 2 over 3 and 2 over 3. So either way works. You can always use one way to solve it and use the other way to check if your answer is correct or not. Okay, so I think that's all we got for this question. Okay. So let's leave a comment here. Okay, so our next question is asking us what is sine negative 90 degrees. So first recall the sine function is an odd function, which implies sine negative theta is equal to negative sine theta. Right. And then recall the unit circle. Which is something look like this. So that's 1, 1, negative 1, negative 1, and that's 0, 0. We got sine 90. Right, so we got 90 degrees, which is right here. And at this point, the coordinate is 0, 1. Thus, sine 90 degrees is equal to 1. And therefore, negative sine degrees is equal to negative 1. And from the formula above, sine negative 90 is equal to negative sine 90 is equal to negative 1. So we can write our conclusion here. Therefore, sine negative 90 is equal to negative 1. Right, so let's leave a comment. Is correct. All right. So coming up, we have our question asking us, how do you find the value of sine 60? All right. So first, let's recall our Pythagorean theorem. Recall Pythagorean theorem, which is given by a squared plus b squared is equal to c squared. Right. And the second thing would be our special triangle. Special triangle with 30 degrees angle, 60 degrees angle, and 90 degrees angle. Right. So let's draw the graph. So here's 90, 60, and 30 degrees. Right. And the special kind of triangle having sides of the same basic ratio and properties below. So that's 2a, and that's root 3a, and that is a. And I'll just write a characteristic on the side. So the short leg is opposite the 30 degrees angle, measures A, which is right here. And the long leg is the leg opposite to the 60-degree angles. And its length can be found by multiplying the short leg by root 3. So that's the long leg, and our hypotenuse, so the length of the hypotenuse is always double the length of the short leg, denoted as 2a in this case. So that's like a double of the short leg, because the short leg is a, so the hypotenuse will be 2 times a, which is 2a. Right, so by knowing all this, let's go back to the question. So we have sine 60. And so this is equal to ln or long leg over hypotenuse. So we will have root 3a over 2a. So we can just get rid of a. We will have root 3 over 2 left. And let's use our calculator. So root 3 divided by 2 is 0.8660. Yeah. So now we can write our conclusion. So sine 60 is equal to root 3 over 2, and this is in the fraction form. And also it is equal to 0.8660, which is in the decimal form. So I think that's all we have for this question. Okay. So coming up, we have our next question asking us what is root 289. Yep. So first, we express the 289 as a product of its prime factors. Of its prime factors, which is given by 289 is equal to 17 times 17. And therefore, we just need to apply the square root. So we'll have root 289 is equal to root 17 times 17, which is equal to root 17 squared. And we can now cancel out the square and the square root symbol since we do not have other operations inside the square root. So this is just going to be equal to 17 itself. So now we can write our conclusion. Therefore, root 289 is equal to 17. Yep. So that's all we have for this question. And also, I'll just do a little bit of review about some other common perfect square. So if we go 121, and if we take a square root of that, this is going to be equal to 11. And if we got a 144 and we take a square root of that, this is going to be equal to 12. And then if we got 169 and then we take a square root of that, it's going to be equal to 13. Oops. And then if we got 196 and then we take a square root of that, it's going to be equal to 14. And if we got 225, we take a square root of that, it's going to be equal to 15. And if we got a 256 and we take a square root of that, it's going to give us 16. Yeah. So those are some common questions we usually come across. Okay, so let's leave a comment. All right. So our next question is asking us, what is the unit circle? Okay. So in mathematics, a unit circle is a circle with a radius of 1 unit. So let's write down the keyword radius of 1 unit. And in trigonometry, the unit circle is a circle of radius 1 centered at origin 0, 0. So centered at 0, 0. And so the point of the unit circle is that it makes other parts of the mathematics easier and neater. So for instance, in the unit circle, for any angle theta, the trig values for sine and cosine are clearly nothing more than sine theta is equal to y and cosine theta is equal to x. So let's write that down. Sine theta is equal to y, cosine theta is equal to x. Right, so first let's draw the unit circle. So that's x-axis, y-axis, and we have a circle, right, and we'll let that just 1, 0, because its radius is 1, and that's 0, 1, that's 0, negative 1, oops. And that's negative 1, 0. Okay, so let's say we got a 30 degrees, which is something look like this. So that's 30 degrees, and we know that 30 degrees can also be represented by pi over 6, where pi is just 180 degrees. Pi over 6. And at this point, the coordinate is root 3, 2, root 3 over 2, and 1 over 2. Right. And then for say we got a 45 degrees. So that's 45. We have our coordinate as root 2 over 2, root 2 over 2. And if we got a 60 degrees, the coordinate is 1 over 2, root 3 over 2. Okay, so let's go to the second quadrant. Let's say we got a 120 degrees. Oops. So that's gonna be 2 pi over 3. And this point, the coordinate is negative 1 over 2, root 3 over 2. Recalling that because we're at a second, we're at a quadrant 2, so the x coordinate should be negative, Well, the y-coordinate should maintain positive. Right. So another example, let's say we got a 150, which is 5 pi over 6. And the coordinate is negative root 3 over 2, 1 over 2. Yep. And so I'll just give one example from both 3 and 4. So let's say we got a 240 degrees, which is 4 pi over 3. And at this point is negative 1 over 2, negative 3 over 2. Because we're at the quadrant 3, so both x-coordinate and y-coordinate are negative. Yep, and here, let's say we got angle at 7 pi over 4. The coordinate should be root 2 over 2 negative root 2 over 2. Yeah, because we're at the fourth coordinate. So the x-coordinate should be positive and the y-coordinate should be negative. Yep. And also, so the circumference of the unit circle is 2 pi, and an arc of the unit circle has the same length as a measure of the center angle that intercept the arc, and also because the radius of the unit circle is 1, so the trigonometric function sine and cosine have special relevance for the unit circle. Yep. So I think that's all we have for this question. Let's leave a comment there. So coming up, we're asking what is the formula of the surface area of a cylinder. Okay. So first, let's draw a cylinder out. So it should be something look like this. Oops. Yep. So that's what a cylinder looks like. And so this is the center, and that is a radius, and that's what we call the height. So a cylinder is a three-dimensional shape that has a parallel and congruent end or base. So let's write the keyword down. Parallel and congruent base. And the shape of the base is a circle. Shape of the base is a circle. And in between bases, there's a lateral surface which, when straightened or flattened out, is rectangular in shape. So rectangular. And because of this, the surface area of the cylinder is a combination of the two circular bases and the area of the rectangular lateral surface. So let's write that down. So surface area is equal to two circular bases plus area of the rectangular lateral surface in between the end, between the base. Alright, so if you want to use symbols to represent this, this is going to be area is equal to area of base plus area of lateral right. So since the bases are circular in shape, and the formula for the area of a circle is A is equal to pi r squared. So we can write our equation as A is equal to 2 pi r squared plus a lateral, where we just replace the area of base as its formula, which is pi r squared. And then we need to deal with the lateral surface part. So it is, if the lateral surface is flattened out, it will be a rectangular in shape. Hence, we just need to use a formula for the area of calculating the rectangle, which is area rectangle is just equal to length times width. And in our case, the width of the triangle is equal to the height of the cylinder. So let's write that down. The width of the triangle is equal to the height of the cylinder. Oops. Yeah, so these two are equal. And the length of the triangle oh, that's not triangle, that should be rectangle. Rectangle of the rectangle is equal to the circumference of the circular base. Circular base, which have the formula C is equal to 2 pi r, right? So if we want to better visualize this, it's going to be something look like this. So that's our C, which is 2 pi r, and that's our height. And that is our rectangle. Okay. So by knowing this, we know the area of lateral surface is 2 pi r times h. So a lateral is equal to 2 pi r times h. So we're combining the area of lateral surface with the area of two bases. We will have A is equal to 2 pi r plus 2 pi r h, where this part is our lateral, and this part will be the circular base. All right. So we can factoring out 2 pi r from the equation. So we will get 2 pi r times r plus h. Right. So let's write our conclusion. Therefore, the formula for the area of the cylinder is given by A is equal to 2 pi r squared plus 2 pi r h, where r is the radius of the base of the circular base, h is the height of the cylinder. Right, so I think that's all we got for this question. Okay. So solution is correct. Well done. Coming up, our next question is asking us how to find the square root of 48. Right. So in order to get the square root of 48, we need to use the square root symbol. So step 1, square root symbol, which is something look like this. Oops. Right. So the second step, we need to express 48 as a product with perfect square so we have root 48 is equal to root 16 times 3. And 16 is a perfect square. So steps 3. We need to express 16 in exponential form. Exponential form. Right. So 16s can be written as 4 squared. And recalling what we have earlier, so root 48 is equal to, instead of writing 16, we'll write 4 squared times 3. Yep. So our step 4, we can cancel out the square and square root. And yep, just recall the 4 square. If we want to take the square root of 4 square, it is still going to be 4 itself. So root 48 is just going to be 4 times root 3. Yep. So that's what we have for this question. And also you can always check your answer by converting 4 to a form that is inside the square root, where 4 is equal to root 16, and then root 16 times root 3 is still going to be equal to root 48, which means our answer is correct. Okay, so I think that's all we have for this question. So solution is correct. Well done. Okay. So our next question is asking us to solve ln x is equal to 9. Oops. Okay. So recalling what ln is, so it is the natural log function. So natural log function, and denoted as ln, and it's just the logarithmic function with a base of e, with a base of e. Yeah, so it's a Euler's number. Yeah. Okay, so ln x can also be written as log with a base of e and the x. So let's recall that the log functions are the inverse of exponential functions. Thus, we have, first let's write that down. So log functions are the inverse of exponential function. Therefore, we can have, change the color, log, if we get log with the base of ax, so it's equal to y. This is the same thing as a to the exponent of y is equal to x. So now let's solve the given expression. So we got ln x is equal to 9, so which implies log ex is equal to 9. Right. So as exponential functions is the inverse of the log functions, we can also represent this by e to the exponent of 9 is equal to x, where x is just equal to e to the exponent of 9. And this should be equal to e to the exponent of 9 is equal to 8103.0839. Yeah. So that's all we have for this question. And always remember, whenever you come across a log function, always think about the exponential function is the inverse of the log function. Yep. And let's leave a comment there. Good job. Oh, cool. Yep. So I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you would like to submit your own questions, please within the links in the description. Remember to leave a like and a comment and share this video with your friends. And this has been Andrew from